Welcome to Science and Engineering World, where we do mathematics, more mathematics, much more mathematics.
Hi Grandpa, what is this?
Let's ask Grandma.
It is almighty or quadratic formula. It's easy as A, B, C.
Great grammar, that is how to describe it, as simple as A, B, C. I welcome everyone to class. This will be our fifth and final presentation in our study of quadratic equations. For now, I put the links of the previous videos above and in the description box below. We started with the derivation of the completing the square with the use of this standard equation ax squared plus bx plus c equals to 0. We then demonstrated completing the square method with the use of a particular quadratic problem, 2x squared plus 11x minus 40 equals to 0. Then we also walk through factorization method with the same problem. Also, we now demonstrated this same problem with graphical methods. Now, we want to look at this same problem with what is called almighty or quadratic formula. My name is Olutola Fakehinde. Like I said in the introduction above, we started with completing the square method using this standard equation ax squared plus bx plus c equals to 0. Watch that video, it is very important because at the end of the derivation, we came up with this wonderful formula. This wonderful formula, known to some people as almighty formula, is often called quadratic formula. It is employed to find the roots of quadratic equations such as this standard equation with our variables as x. It says that x equals to minus b plus or minus square root of b squared minus 4ac over 2a. It is known as almighty formula because it can solve almost all quadratic equations. Let's demonstrate the use of this almighty formula in this presentation. We have used three methods. 1. Completing the square method. 2. Factorization method. And 3. Graphical method to a particular equation 2x squared plus 11x minus 40 equals to 0. And in all these three methods, we've obtained the same roots of this equation. Now, we want to employ quadratic formula to this same equation, and we hope to obtain the same roots of this equation at the end of this presentation. Now, let us see the solution to this quadratic equation 2x squared plus 11x minus 40 equals to 0 using the quadratic formula. As we've done previously, we shall be going steps in the solution process here. Step 1 here says we should match or compare the coefficient of the standard equation ax squared plus bx plus c equals to 0 with the equation we want to solve, which is 2x squared plus 11x minus 40 equals to 0. We've talked a lot about the coefficients, so we should refer to the videos above. Now we want to compare the terms of these two equations. The first term here says ax squared and 2x squared. In ax squared and 2x squared, we will say that ax squared is compared to 2x squared. The second term is bx. So we have bx on the left hand side and then plus 11x on the right hand equation. So we have bx compared to 11x. The third term is c. So we have plus c on the standard equation and minus 40 on the equation we want to solve. So we have c will be compared to minus 40. What are the coefficients? For the first term, a is the coefficient for the standard equation and 2 is the coefficient for the one we want to solve. The second term, b is the coefficient on the other equation plus 11, and then c is the coefficient on this side and minus 40 is the coefficient. Step 2 is substitution process, and we have seen in step 1 that a is being represented by 2, b represented by plus 11, so the 11 we can just write plus or just 11. Then we have c is represented by minus 40. So the next thing now is to bring all this into the almighty or quadratic formula, and this we want to substitute. Like grammar said, this is as simple as ABC. So we have the values of A, B, and C in this quadratic formula. We need to now substitute the letters in the quadratic formula with the numerical values that we have in the comparison here. B, the first letter in the quadratic formula, will disappear to give room for its value here, which is 11. And the second b in the square root will also disappear to give room for its value 11 again. The next letter in the square root is a. The a will also disappear to give room for 2, which is its own comparison. And c will also disappear to bring in minus 40. The a in the denominator will also go to give us 2 in replacement. And that is it. As simple as ABC, like grammar said. In step 3, we want to simplify the right hand side, which is this side. Here we have 11 minus 11 will remain minus 11, but 11 squared, that is going to give us 11 times 11, which is 121. And then we have here this inner term to be minus 4 times 2 bracket minus 40. Minus 4 times 2 will give us minus 8 times minus 40. So minus times minus is plus, 8 times 40 is 320. So that is plus 320. And then we have in the denominator 2 times 2, which will give us 4. So we now put these values into that expression, and we now have x equals to minus 11 plus or minus 121 plus 320 over 4, and 121 plus 320 will give us 441. So we now have that square root of 441 is equal to 21. So we now have x equals to minus 11 plus or minus 21 over 4. Now because we have plus or minus here, then we are going to have two roots of this equation like we have been having before. In step 4, we want to find x. And because of the plus or minus we have here, we are going to have two values of x. So the first one will be minus 11 plus 21 and minus 11 minus 21 over 4. Minus 11 plus 21 is 10 over 4, or minus 11 minus 21 is minus 32 over 4. 10 over 4 is 5 over 2, and minus 32 over 4 is minus 8. These are the two roots of the equation we obtained earlier on. Alright, step 5 is verification process to verify if the roots we've obtained are in agreement with the equation 2x² plus 11x minus 40 equals to 0. Because this is the same equation and we've also arrived at the same roots, this verification process has been done in the previous videos, so I will encourage us to go through that and look at it. However, this is just a snapshot of what it is all about, and so we've been able to verify from the past that x equals to 5 over 2 and x equals to minus 8 are in agreement with the equation 2x² plus 11x minus 40 equals to 0. Now, using quadratic formula, we have been able to arrive at the roots x equals to 5 over 2 and x equals to minus 8. So it's not interesting to know that all the four methods we have used are in agreement. That is, the completing the squared, the factorization, graphical method, and quadratic formula have given us the same roots of the same equation. If you find this presentation useful, give us a thumb up. Make comments. Let us know if you have any concerns or question you have in your mind. Subscribe to this channel to encourage us so that we can do more videos like this. Mathematics is fun, so keep having fun, and until we meet again, keep studying.